Okay, today we're going to do the next section on logarithms. Yesterday we looked at converting equations and solving equations and so on, and there was two formulas on the formula sheet that we use often. The first one is converting back and forth between an exponent and a log. So the key thing to remember with this one is when you have the exponent equation, the exponent, the x in this case, becomes your answer, and then the base, the a, is still the same, and the y that was your answer now is the number after the log. So probably that's the most important thing. Remember how to convert from one to the other and make sure you get that right. And then the second one that we looked at yesterday was how do you solve a log that's not a base 10. Remember a log by itself, so I gave you log 7 is actually log base 10 of 7. And that's how you could do it on your calculator. So if you get something that's not base 10, like log 3 of 5, remember a good way to solve that on your calculator is just go log 5 divided by log 3, because we're making both of them base 10, so then it works just fine. So what we're going to look at today is there's 3 different logarithm laws that are on your formula sheet. We're just going to go through each of them to make sure you understand how they work. So, and they're very similar to the exponent laws. If we remember back to exponents, if you have x to the 3 times x to the 5, the rule was if they're multiplying the exponents, you just add the powers. So you'd have 3 plus 5 gives you the 8. So because that works like that, the logarithm one is almost the same. And on your formula sheet, how they write it is log a of m times n. And that you can change it to log a of m plus log a of n. Okay, so that's the first of the formulas that you're going to use. So it's just basically taking, either you get the question where they're added together, so you have log of one number plus log of another, and you merge them together to be multiplying, or the other way around. So let's try one quick example. So if I gave you log 2 of 5, and we're going to add log 2 of 25.6. Okay, and you can have these in brackets or not, it doesn't really matter. Sometimes you see them with, sometimes you see them without. So if we use this formula we just did, but in reverse order, so that would be the same thing as log 2 of 5 times 25.6. And if you simplify that on your calculator, 25.6 times 5 is 128. And then at this point, we got a couple different ways to solve it. The easiest is maybe just use that new log rule that we have. Just go log 128 divided by log 2, and that will equal 7. So 7 is your answer for that, or let's just kind of remember how we could have solved it the other way. So let me rewrite log 228, that was our answer that we came up with. So the other way we could do that is change it back to an exponent form. So you'd have 2 to the power of something equals 128, sorry. I might have messed up. Let's go back to the last page. Nope, that's right. So I had log 128 divided by 2. Okay, so we can change this back to an exponent form, because really what we're doing is we're trying to figure out what is log 2 of 28 equal to. So if we rearrange it, we'd have 2 to the x equals 128. And then just like we did in the exponent section, we can change 128 to 2 to the power of something. And if you trial and error on your calculator, 128 is the same thing as 2 to the 7. Therefore, we get x equals 7. So either way, either use the logs formula, the new one, or change it back to exponents, we get the same answer either way. And we're actually going to do a third way of actually figuring these out, but I'll get to that in a minute once we learn the new formula. So just like multiplication law, in exponents we had a division law as well. So for example, if I gave you x to the 12 divided by x to the 5, in the exponent laws we did, when we solved that, we actually subtracted. Because we're dividing, we subtracted exponents. We got x to the 7, so the same sort of log law applies here. If we have log a of m divided by n, we can actually, because they're being divided, we could break that apart and have it as a subtraction. So log m minus log n. Okay, so that's the second of the log laws that are on your formula sheet. So let's do an example with with this formula. So for example, if I gave you log 6 of 144 and we subtracted log 6 of 4. With both of these formulas, you notice the log base number, the a, has to be the same. So in this case, we both have log 6's. If they're different numbers, you can't do nothing. You just leave it the way it is. But because they're both the same, we can actually use this formula. So that means it would be the same thing as 144 divided by 4. And if you do that division on your calculator, you'll get 144 divided by 4 being 36. And just like the last question, we can either change it back to exponents, or you could just do the division, log 36 divided by log 6, whichever way you want, and that'll give you an answer of 2. Okay, so that's it for the first two log laws. There's one more that's on the formula sheet, and it's sort of a multiplication one, but it's a little bit different than the exponent laws, so we won't bother with comparing it to an exponent law one, but the way it is on your formula sheet, they have log a, and then they have m to the power of n, and we can write that by changing it to being n times log a of m. So what that means is, if you kind of look at this formula, we can convert back and forth by taking an exponent and moving it down in front, so it'd be n times that, or vice versa. So if the question gave it to you where the n was already in front, you can simply just move it up as an exponent. Okay, so either way, it's just basically flip-flopping those formulas one way or the other. So let's look at an example for this one, and you'll see how it works. It's very, very handy, and you're going to actually use this formula quite a bit. So log 5 of 25 squared, if that was the question, we basically can rewrite it as 2 times log 5 of 25. And then we can just solve the log part, so log 25 divided by log 5. And if you actually do that on your calculator, log 25 divided by log 5 is 2, so that'd be the same thing as 2 times 2, which is 4. So that's kind of how that one works. Before we quit for today, I just want to show you one other practical application of this one. So if I gave you, let's suppose we do log 6 of 6 cubed. So using this new formula, we know that that's the exact same thing as 3 times log 6 of 6. And from yesterday, we know that log 6 of 6 can be written as log 6 divided by log 6. But because you have log 6 divided by log 6, they're both the same. Those actually cancel out, and you just get a 1. So this formula comes in handy because if you can ever change it so that the log number and the base number are the same, then your answer will basically just be whatever that exponent is, because you can bring that exponent down in front and it'll just be like 3 times 1 like it is in this case. So what I want to do is we're actually going to go back to the last couple examples I gave you, and let's just kind of take a quick look. If you see that the first one we got log 2 of 28, we can actually solve that a different way now that we know this rule. Okay, so we did the division, we went log 20 divided by log 2 and got 7, or I showed you we could change it back to an exponent and we got 7. But another way of doing this is you can actually change it to be log 2 of 2, because we know that equals 1. We know that 28 can be changed to 2 to the power of 7. So because of that, we know that that's going to be the same thing as 7 times log 2 of 2. And log 2 of 2, because it's the same number, is just 1. So we get our answer of 7. So it works just like we did before. We get the same answer, but it's sort of a different way of approaching these. The second example we got, our answer was we got log 6 of 36 was our sort of final simplified answer. So let's take a quick look at that one. So if you had log 6 of 36, sort of the same thing, we could rewrite it as log 6 to the 6 squared. Right, 6 squared is 36, so that would be 2 times log 6 of 6. And log 6 of 6 is just 1. So our final answer is 2, and that's what we got when we did it the other way too. So it's a handy formula to help you solve these. You don't always have to just do the division. You got a few different options. One last example to look at. Let's look at one that is sort of a combination. So if I gave you log 7 of 112, 2, and we're going to subtract 2 times log 7 of 4. Okay, so the question would be simplify and solve this. So when you look at this, we're kind of combining all the different log laws that we looked at today. We can't combine them because of that 2 in front, right? The formula has to be just log 7, log 7. So the first step is to get that 2 up as an exponent. So we want to use that last law that we just did, and we want to change it so that it would be log 7 of 4 squared. And then we know that 4 squared is 16, so we can change that to log 7 of 16. And now we have the same bases, we have a minus, so we know that that has to be the division law. So we can then rewrite it as 112 divided by 16. And if we do that, 112 divided by 16 is 7. So all of this will simplify down to log 7 of 7. What is log 7 of 7? We know that that'll cancel it and just be a 1. So all of this work for this question, we basically boiled down to the answer of just being 1. And that's it for the log laws. So all of these formulas are on your formula sheet. So use them wisely. Every question they give you on the diploma is always just basically reverting to one of these formulas and being able to use them. And that's it. So try the assignment 7.3, and that'll be it for today.